Hello everyone. Today we are going to do experiment 14.1, making a parallel plate capacitor and storing charge. Okay, so we're going to need styrofoam plate. We know styrofoam is insulator. It won't conduct charges. And we're going to need 2 pieces of foil. So you're going to use a square of foil. You can push the foil on the bottom of the plate, and then you use your hand to make a crease, and then you cut the foil off. You need 2 pieces. One piece is you're going to tape on the bottom of the plate. The other piece of foil we're going to tape on the top of the plate. Okay, and then you connect 2 pieces of foil. You can use the remaining foil, cut 2 pieces about 1/2 inch width, wide, and about this long. And one piece you tape on the bottom, the other piece you tape on the top. Okay, we're going to use that as a conductor. And on the top one, the book said you use paper clip. But as I tried, I think paper clip doesn't work that well because you cannot make sure the paper clip connect very well with the foil. So instead of paper clip, I use another piece of foil, okay, as a conductor. And then you can cover the bottom with another plate to ensure the charges won't run away from the bottom. Okay, the only way they can run away is through the 2 pieces of foil. One connect to the bottom, one connect to the top. Okay, this way you made a parallel plate capacitor because you have a 2 conductor, both on the metal, and they are parallel to each other. But they are separated by an insulator. So we call this parallel plate capacitor. Okay, with this way they can store. We will see how they store charges. Okay, so first thing we're going to use we're going to use a balloon. Okay, you're going to get charges from your hair. Use the balloon. Okay, so you're going to rub your hair with the balloon, and then you try to transfer the charges on top of the foil. Okay, so you're going to do this 10 times. At the same time, make sure you use the other hand to hold the foil connected, which is connected to the bottom foil. Okay, you can connect that foil piece and then transfer the electron on top onto the top foil. Okay, so you can imagine when we transfer the electron onto the top foil, which happens to the bottom foil, because the electrons are negative charges, and the negative charges in the bottom foil will going to be pushed away from the top foil, because they're negative charge on top, so the negative charge on the bottom want to run away from the top. So you're going to, because you hold the strip connected to the bottom, so the electrons from the bottom foil will run away through your finger to the ground. Okay, because like charges repel each other, so the electron from the bottom foil will be pushed away, and what's left is the positive charge. So there will be positive charge in the bottom foil stored here, because the electron run away through your finger to the ground, but the positive charge is left. because the positive charges are attracted to the negative charges on top of the foil. They are attracted to each other because that, how to say, different charges attract, so they attract each other. So this way, the positive charges are stored up in the bottom. As when we put more negative charges on top, more positive charges will be stored up in the bottom foil. All the negative charges from the bottom foil run away through your finger. We do this 10 times, okay? I don't remember how many times I did, but that's it. That's the way you do it. And okay, and then after this, you do this for a while. You put the balloon away and finger away. Now imagine, on top of the foil there's negative charges. On the bottom foil there are positive charges. So there are electric field there. Now you use your finger, one hand to hold the positive end, the other hand to touch the negative end. So you're going, because your body acts as a conductor, so there will be electric flow through your body, and you're going to feel a tiny stroke as you get near to the positive end. Okay, you're going to feel a tiny stroke there as you close the circuit. Okay, that's how you do this lab. And you can, for the second part of the lab, you repeat the experiment one more time. You collect the electrons on your hair and put the electrons on top of the foil. At the same time, you hold the foil pieces connect to the bottom, and then this way you store the positive charge on the bottom of the foil and the negative charge on the top of the foil, and then you're going to put the balloon away, and you're going to stay away from your plates, okay? And you can wait maybe an hour, and then when you come back to check, you, like before, you one hand hold the bottom, the other hand touch the other foil piece connect to the top, and feel what happens. You should feel a tiny stroke there. That's because that's the same reason. That's just show that because when you store up the charges, negative charge, positive charge, they attract each other, so that you won't lose the charges easily, because they attract each other, so they hold them. So that's why it's called a capacitor. It can store up the charges because they different charge they attract each other, so you won't lose them unless you like use a conductor to touch each end, and then you will lose, or one end you will lose the charges to the ground or to your body, to candle, you will lose charges. Otherwise it will store up. Okay, that's how you do today's experiment. And then you can give me a report. Please explain how you did it, and also why this happened. Please explain why this happened. Okay. Yeah, that's it. Thank you. Bye.